Okay, so I am back. So in the last video, we finished with answering this question here. Okay, so how do photosynthesis and cellular respiration demonstrate that conservation of matter? Well, we can see that every atom of carbon, hydrogen, and oxygen that goes in as an input or reactant equals the number of atoms that come out as outputs or products. So let's actually look at that a little bit closer together. So you don't have to do this on your document, but I'm just going to record some stuff here. So I want to go through kind of how we read this and how we count up our atoms so that I can prove to you this conservation of matter. Now we know that cellular respiration and photosynthesis, when it comes to these 4 core molecules, they are the same, it's just that it is in reverse, it is backwards. So we have our reactants here are the same as our products for photosynthesis. Our reactants for photosynthesis are the same as the products for cellular respiration. So I'm only going to focus on one of these equations when I'm counting up these atoms, but you'll see that the atoms are the same for the reactants as they are for the products. It's just that the configurations have been changed so that we are seeing different molecules. Okay, so how do we read this? Well, we have glucose here. This subscript after our carbon, the C here, is telling us that there are 6 carbon atoms. And actually, let me make this a little bit bigger. Woo, maybe not that big. So there are 6 carbon atoms. There we go. So next to it is hydrogen. This tells us that in glucose, there are 12 hydrogen atoms. In glucose, there are also 6 oxygen atoms. Okay, so within glucose, we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. And we can see that if we look here. So we have, 6 carbon, 6 oxygen, and what I say, 12 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah, 12 hydrogen within 1 glucose molecule. Okay, what goes into cellular respiration is also oxygen. So looking at this, we have oxygen. There is a subscript of 2. So what they're referring to there is 2 oxygen atoms are bonded together, and we have 6 of them. So we have 6 of these O2 molecules where 2 oxygen are bonded. So how many oxygen is that? If we total it up, that means an additional 12 oxygen atoms. Okay, so that's another 12. I'll just write that here. But 12 plus 16, 12 plus 6 means that in our reactants, we actually have 18 oxygen atoms. Okay, so for our reactants, here are the amounts of atoms for carbon, hydrogen, and oxygen that are present. Okay, so what about our products? let me just change the color. So for our products, let's do green. We have carbon dioxide, and this is telling us that if we have 6 carbon dioxide molecules that are being created, we're going to get 6 carbon atoms. For oxygen, again, we will get 12 oxygen atoms out of this. So for CO2, we have 1 carbon atom that is bonded to 2 oxygen atoms, and we have 6 of those molecules. Okay, so that totals up to 12 oxygen total. Next, we have H2O. So water, it is 1 oxygen atom bonded to 2 hydrogen atoms. We have 6 of those molecules being created. So we have 12 hydrogen atoms plus 6 oxygen. And I'll go ahead and add the 6 to the 12 here. So we have 18 oxygen atoms. Okay, if this was confusing, I understand. It is okay. It's not like we need to memorize that. But this is a good intro for anybody, like for like chemistry and stuff, so that we kind of understand how to read these chemical formulas. And really it's just a good image, like a good I'm trying to think of the word that I want to use. A good way for you guys to visualize how we have the same number of atoms for carbon, oxygen, and hydrogen for both our reactants and our products. It's just that the atoms are changing form. As they go through that process, they are being changed into different molecules. Okay. So, like I said, you don't have to do this on your page. I just did it for this video to show you, so that we better understood what I'm talking about here. But how every atom of carbon, hydrogen, and oxygen that goes in as an input equals the number of atoms that come out as outputs. Okay, so another question that we're going to do together is how do photosynthesis and cellular respiration show the flow of energy? Well, as we can see in our model up here, and I'll show that once I'm done typing, light energy is converted to stored energy in glucose, and then through cellular respiration, that glucose is broken down and released as ATP, or what we've been calling usable energy. Okay, so as we can see in this diagram, we have light energy, and through photosynthesis, that light energy is converted to like chemical energy that is stored within the bonds of our glucose molecule. Through cellular respiration, we are breaking these bonds, so we are breaking down the glucose, and that chemical energy is then used to create ATP, okay, to create a usable form of energy for us. Okay, So there are a few more questions that need to be answered. There is one more that I want to make sure I cover, because I know I didn't cover this part of the exit ticket for, I think 2 of my classes. So I'm going to quickly go over number 10. And beyond that, I think you guys can complete the rest of this. I will include a key for 1 through 12 here. Obviously I'm going to talk about the answer of 10 right now. And then there's 2 down here that are considered big ideas. I don't want to outright give you the answer for that right now, but when I see you again in class, I want to talk about these 2. Okay. So for number 10, it says explain specifically what happens to the process of photosynthesis if plants are kept in the dark. Okay. So in our photosynthesis exit ticket that you were assigned a few days ago, there's a short video for you to watch about plants, and it talked about plants going through photosynthesis and cellular respiration. So what happens with photosynthesis if plants are kept in the dark? Well, remember that photosynthesis requires sunlight. It requires light energy to actually run, to happen. So if plants are kept in the dark, if they don't have sufficient sunlight or sufficient light energy, photosynthesis will not happen. Okay, so for number 10, if plants are kept in the dark, photosynthesis will not happen. Cellular respiration can happen as long as there is enough glucose. If there is no glucose, if the plants are in the dark, there's no light energy to help them perform like photosynthesis and create glucose, the plant won't even be able to go through cellular respiration. So I will write, without sunlight or light energy, they, and the they here obviously are plants, they cannot perform photosynthesis, and they would stop creating glucose. So it is very important that our plants get sufficient sunlight. If anybody has ever had a plant in the house, you can tell pretty quickly if your plant isn't getting enough sunlight, because they will not do so hot and will end up unfortunately dying because they cannot perform photosynthesis, and eventually they can't perform cellular respiration either, because they won't have the glucose that they need. Okay, so your task for today is to continue with these notes, answer these questions to the best of your ability, then cross-check them with the key that I've posted, and the next time you see me, expect to talk about these 2 questions down here, these big ideas. Well, let me know if you have any questions about this activity, and I hope you guys have a great day, and see you when I see you again.